Yeah. You also.
Yeah, that would, that's what I meant to say.
Okay, you could just plug in one. Copy derivative. Let's find the equation. You need to find one. You can't just plug in one.
Okay, let me pull the test review. Okay, are there any ones that you want me to go over in more detail with you? Or ones that you want to see more examples of? Any questions or what are your thoughts?
A lot of things with the tables, I have a hard time understanding.
Okay, sure. So on page 3, we have 17, and then we also 18 is more. 18 and 19 are more for derivative of inverse at a point. But for 17, I think that is one where we have to just identify the need for quotient and a little bit of chain, and to kind of walk through that process, building that derivative, and then plugging in 3 for all of the x's that we see. So I'll walk through this here. So this is definitely a need for quotient rule. So my f prime is my top portion. So my f is g of x, so g prime times the original denominator, no changes, minus the original top, no changes, times the derivative of h of x to 1/2. Now this is a function within a function. I got to go through chain rule here. So there's an outside and inside portion happening here. The outside is the parentheses to the 1/2, and the inside is that h of x that you see there. So we have to take turns with each derivative and build out our chain rule. So parentheses to the 1/2 becomes 1/2 parentheses to the negative 1/2. Leave that h of x intact, times the inside's derivative, h becomes h prime. So that all that work is just to get to g prime within my quotient rule, all over my denominator squared. It's the hard part. The hard part is to build out that derivative. And the rest of it, you're just making sure that you're careful. You are reading the table and finding those values that come from the table.
Okay.
Yeah. Can be a little messy there, but I mean, I will probably still accept the answers, even if it's incomplete, or even if it's not completely reduced, because if I know that you know where those numbers are coming from, that's essentially the same as negative 16 over 27.
All right, at what point on here would you say you get full credit still?
I want to see you attempt. How about this? I want to see you attempt getting to the answer. But if you make a small mistake, I won't take off points, because I see that, okay, that's just a numeric error there. Your process, you understand the process, I'll still give you credit.
Okay. And then also, I think I was absent when we went over natural logs.
Mhm.
Just kind of shaky on that.
Okay. So let's pick out some problems there on page 4 here. So the rule for if you see natural log is u prime over u. So for number 2, you can see that sine of 5x is clearly in that inside that natural log expression. So we have to just follow the rule. And the rule says take the derivative of sine 5x, put it in that numerator slot, and then take the sine 5x and keep it in that denominator. So we basically have to ask ourselves, what is the derivative of sine 5x? And that is going to go in the numerator space because that's what it's asking for natural log of u. So the derivative for sine of u, got to go through another rule here because it's rule inside a rule here. So sine of u becomes cosine of u times u prime, and that takes care of the derivative of this expression inside the parentheses, all divided by the denominator expression. So from here, it's okay if you leave it in this form, but we can clean up further by doing cosine over sine as cotangent, but this will give you credit. For number 3 here, we have to recognize there are a need for product rule. X and natural log of 4x are obviously connected by multiplication. We can't merge it into one term. They're treated as separate. So we got to do f prime g plus fg prime. Every time you see natural log of u, you can just do u prime over u.
Okay. And what if the u natural log has an exponent? Because I've seen that a few times.
Got it, right. So okay, we have a couple of properties that allows us to clean things up before we apply derivative rules. And I'll go over those properties here. So here's a good instance of taking full advantage of the properties before you find the derivative. Let's say my equation was this. Now, I could do u prime over u, but this is kind of a messy problem to have to go through that. So why not we take advantage of all the log properties? We can just split everything up into much easier bite-sized portions, and then we can do the derivative for natural log. So here we see the big relationship here is that the numerator and denominator is quotient property. So I'm going to think of this as natural log of the square root of 3x squared minus 4 minus natural log of x to the 7. So automatically, or just from that one step, I'm able to kind of split this into 2 problems, and I can treat them independently of each other. Second thing is anything that I can rewrite as a radical, as a exponent in my natural log gives me a really nice property, is that this exponent can just be free to move down. Okay, normally I can't do that. Normally I can't just move the exponent down and without changing the value. But here in natural log, that's the beauty of it. I can bring that exponent down rather than thinking of this as our u value, u prime over u. Our u value is not a lot cleaner with that 1/2 out of the way. There's no need for a messy chain rule because I can bring that 1/2 down. So and this one, you can leave it up. It's not that big of a deal, but if you want, you can also bring it down. Maybe that is make it just to kind of fully show the properties at play here. So you would much rather find the derivative here than up here, right? Because this is really messy. But the nice thing about these properties is you can just get it all the way to this point, and then we can just simply apply our natural log rule twice. And we have 2 separate u values. We'll do u prime over u, and then the coefficient just hangs out in front. Okay, so y prime equals, okay, natural log of u becomes u prime over u. So what's my u prime? Over 3x squared minus 4, okay? And then the 7 is a coefficient that's going to stay. What's natural log of x? Okay, that's my derivative. I'm going to maybe do a little bit of cleanup. I'm not going to ask you to do common denominators, but maybe just within each fraction, you can kind of just do some cleanup here. So 3x over 3x squared minus 4 minus 7.
So on number 9 on that page, the equation has like, it's a product rule, but then you have to do chain rule for when you're finding like x prime. So does chain rule or product rule like take precedent? Like which one do you need to do first?
Yeah, it's a good question. For number 9, right? Number 9. Okay, let me, is everyone okay for this so far? It's okay. So the question is, if you have product and chain rule, how do you know which one to do first, right? Because you know there's 2 rules involved potentially, so how do you decide which two? So the key thing here is you look at what is impacting the problem at a larger level. So let me give you 2 examples here. Okay, so do we see the need for a product rule here? Do we see a need for a chain rule here? Yes, okay. Do we see a need for product rule here? Do we see a need for chain rule here?
Yeah.
Yes, okay. But the order is going to be different from both of these. So the question here is, so the way you can tell is you look at the parentheses, okay? Now, between product rule and chain rule, which has a larger impact? Which is impacting a larger portion of the problem? Chain rule. So chain rule is going to come first. Then once you're into chain rule, outside, inside, then once you get inside, then you can do your product rule. So whatever has a larger reach in the problem is going to be what you do first. So this one here, which one has a larger impact on the problem? Product rule. So that's why the product rule is impacted first. And then once you're inside product rule, then your chain rule. Okay. Maybe an easier way to think about this is you look at the parentheses. If your parentheses is over everything, then chain rule is going to come first. But if your parentheses is not over everything, that means something else is at play. So you're going to take your other rule first. In this case, it's product rule.
Thank you.
You gotta go. You want to come tomorrow morning?
I'm fine too.
Okay, so, okay. I'm gonna stay longer. She has to go early. But what else do you guys want to talk about? Okay.
Thank you.
Yeah, sure. All right, see you, bro.
Like all the specific, but let me find some,
Mm-hmm.
there was like one problem. So for, it was page 250 and it was, problem 41.
Section is that?
It's derivative, composite, implicit, and inverse functions.
Okay.
It's 27 on the packet.
Oh, wait, back.
Yeah.
Okay. So it's the. Okay, I see. That's a messy problem.
It was like one step, which I didn't, I saw the like key, but I still didn't check it.
Okay, so, right, this is a good thing to see. Okay, there's definitely chain and quotient involved, but you look at the parentheses is not over the entire thing, so quotient rule is gonna get applied first, and then once we get to the parentheses, we're gonna do the chain rule portion. Okay, so f prime g minus f g prime. Once we get to g prime, that's where our quotient rule, our chain rule gets activated, all over denominator squared. And I'm just trying to clean up within each portion here. This I can clean up to be just one. That's nice. Here, I'm gonna treat this like one. This is kind of like a separate fraction up here. So I gotta do a complex fraction here. So I'm just putting all the numerators and denominators together and then just forming my own fraction up here. So are you good up to this point?
Mhm.
Okay. So think of it this way. Here, we can think of this as finding common denominators. Maybe I can work it out that way here. You can find common denominators for this portion. And then once that's cleaned up, you can bring that 1 minus x squared and incorporate it into your derivative. But hold on, but maybe I didn't even go that far. I think what I did was I just thought of it as, okay, anytime I'm thinking of this as quote unquote one term, and I'm just splitting up into two fractions. I'm saying this fraction, this expression is anything as this over this plus this over this. So I'm able to kind of split up into their own regions. And this is basically done. Right? I'm just trying to find a way to clean this up. So the way I clean that up is I can bring this to the top and think of it as multiplying the reciprocal, which is 1 over 1 minus x squared to the first power. And then now that I have 1 minus x squared to the 1/2 and 1 minus x squared to the 1 first power, I can add exponents. 1 plus 1/2 is 3/2. So that's how I got to that. But I mean, if you leave your answer like this, or even like this, I will give you 4 credit. I just want to show you, where an AP exam, multiple choice could potentially lead you down to. It could go here or even go a little further into common denominators. But I mean, if it's true response, I mean, this is fine.
I was confused how you got the 3/2.
I see. Yeah, so I'm just bringing that up and adding exponents.
Oh, where did the, like, negative 2x that you were multiplying by, where did that go?
Oh, where did that go? Oh, this is a 2 here.
Ah.
So I took the 2's out and then I kept the x. And I combined the sign, two negative on the positive there.
Oh, it's number 31. Bio. So this one was on, 3.4,
Okay.
page 33, it was 31.
That it?
Yeah.
The temptation is we want to try to create a log property and we distribute through, but we can't do that. Okay, it's kind of stuck in that form. Now, if it was natural log of x times root x squared plus 4, then that's fair game. Then we can expand. So if it was this, it would have been an easier problem. Right, then I can say natural log of a plus natural log of b, and I can clean up and do u prime over u, but this is kind of stuck in this form. I cannot expand. So I gotta treat this like my inside portion, my u value. So really, there's a, yeah. So I got outside and inside. Basically, I'm just doing u prime over u. So the way I have to get to the u prime is I gotta figure out what is the derivative of this expression. X becomes 1. I gotta go through a little bit of chain rule here. So this is really x squared plus 4 to the 1/2. So I gotta do outside derivative, 1/2 parentheses to the negative 1/2. Do the inside, multiply by the inside function derivative all over my u value. So this is my u prime divided by u. So I worked it out to the point where the book had it, but I mean, we don't have to worry too much about going that far. I mean, this is fine. You can just show me positive exponents. We can go from here. But the way I got even closer to my cleaned up solution is I did common denominator here. Once I found the common denominator, then I push this up to the top and look for more relationships that can help me clean up. So this in the denominator, same thing as multiplying by its reciprocal. And then it just so happens that these two reduces, and I'm able to get all the way down here. But I wouldn't worry so much about the cleanup. If we can, if we can understand, get to a version of the right answer for now, I think that's the most important part. The cleanup is nice, but even on the AP exam, though, you're not going to see a problem where it is this algebraically intense. That's not the focus of BC exam, at least not anymore. It used to be more algebraic. Now they care more about understanding conceptually. So.
So I walked in when you were talking about, like, you said like log, like when you did like minus when it was a fraction or something?
Okay, yeah.
And like, I thought sure frozen.
Yep.
Yeah, you like subtracted it.
Right. So,
So how do you know when to like put the natural log there?
this is just a beginning problem here. This is not something that you create. So let's say I gave you this problem here and you want to find the derivative. So, I mean, you could do u prime over u, but that is such a messy problem, especially with these properties available to you. Why don't we just go ahead and take advantage of a property, split it up into easier parts, and then just handle them independently.
So
that's the strategy.
those are just like properties. I guess I just didn't get that you could just like add when it was multiplied.
Yes, yeah, so, right, so those are 3 nice log properties that, that we use, if possible, before we jump into our derivatives.
You sneeze a lot. Like I feel like you're always sneezing in this class. What about like, I noticed that sometimes like you add a natural log to both sides.
Yep, so, right. If there's already a natural log in the problem, then you never want to add natural log
to both sides, because then you're adding another layer of natural log. That's not gonna help. So when do you add natural log to both sides? Well, there's two instances. One instance is if you realize that you would prefer not to go through a complicated combination of product, chain, and quotient. The nice thing is if I introduce natural logs into this problem, then I can start applying all these properties, break them each down into their individual components, and then we just do U prime over U for each, and it becomes a lot easier to do.
Mhm.
The second instance is where you're forced into it. Let's say I had a variable raised to another variable, like x raised to x squared. Right, I don't have a rule for that, so I would prefer then to find another place for that x squared exponent. So what's the easy way to get an exponent to live in a different location is if we can get it to be part of a natural log expression. That's what I did at the end of class today with log differentiation, where you're forced into going through this because we just don't have a rule that can handle this.
So when you put the natural log onto the x squared, it's like powerful.
It's like power property, right? So we have this power property that says if I have natural log of a to the nth power, this exponent can be free to move down or stay up without changing the overall value. I'm not doing any calculus, but I'm just applying a property that allows me to represent my expression in a different form that's easier to work with.
Oh.
So once that comes down, then I'll do implicit here for the derivative, and then I can go through the product rule. And then solve for dy dx.
So natural log of y is just 1 over y.
Right, dy dx.
dy.
Right, because u prime over u, the derivative of y is 1 over y. We are asking for y's derivative, so we need to attach that dy dx.
Yeah.
Because of implicit.
Okay. Are we gonna have any graphs in this test?
No graphing, no. Joey, any questions?
I'm trying to stop the thing.
Okay.
Review that I had.
Good.
One of them.
Okay.
Of course, done the last days, being property.
Okay, good.
It's funny to look back at my homework because I like circle stuff and now I'm like, oh, well, I understand now.
Yeah, I mean, yeah, you're going through so much, so it's good that you're going back and looking at them. It's. Yeah, some of the AP, especially the AP multiple choice are a little bit stretch problems. Because those are kind of similar to what you might see on the AP exam, but it's a little bit
more than what I'm doing in my class, but it's still good to at least, kind of wrestle through those. Yeah. Make things easier when we get to the springtime, so.
Okay, so, 3.4 AP practice, there, number 4, I circled something, and it was like, I still don't get it, so.
This one here?
Mm.
Okay, so, now that I look at this problem, I could have taken potentially a cleaner path. Because natural log of xy, now what I did was I did u prime over u, and I forced myself to go through product rule there. So let me walk through this process first, and then I'll maybe go through a different way of working through it. So I looking for rate of change. So I'm ultimately trying to get u I dx. Okay, that would show up. So there's my u value. U prime is f prime g plus f g prime. If I want to leave it in this form, I got to go through product rule. But when I get to g prime, it becomes dy dx all over u prime over u equals 1. So are you good with the calculus portion there? Okay, so from here, I just cross multiply and try to isolate the dy dx. Dy dx be xy minus y over x. I plugged in 1. Now, they didn't tell me the y value, so I have to go searching for the y value. So I have to look at the original equation, plug 1 in for x, and then see if I can find out what the y value is. So if I replace 1 in for x, natural log of y equals 1. In other words, what must y be in order for natural log of y to be equal to 1? So y has to be equal to e. Because we know that natural log of b is equal to 1, so therefore y is equal to e. So that's my order pair. My order pair is 1 comma e. I plug 1 in for x, e in for y, and I know we get it all cleaned up to just be 0 over 1, which is 0.
So like, what is E again?
E is it's a irrational number that is part of natural log. So natural log is log base e, which is natural log of x. So e is by 2.72, but it's a value that makes things clean for our functions. So if I have natural log of x, the reason why we use natural log of x so much is because it's got such a nice derivative property about it. That's why we don't do logs of other bases, because it's just it's kind of like the parent function that has a nice property, derivative and order pairwise. So that's how they build derivative functions. So a lot of times we use e because it comes out very clean for us. But yeah, just e is just it's like pi. It's just it's a rational number that shows up a lot in math. So we use them. Another way that we can go about doing this is rather than jumping directly into the derivative step, we can actually just expand, because actually we have that property available to us, right? Natural log of AB can be expanded to natural log of A plus natural log of B. So I can write this as natural log of X plus natural log of Y. Let's see what the X, and I can just find the derivative from this step rather than going through that product. So natural log of X becomes 1 over X. Natural log of Y becomes 1 over Y, dy dx. And if I do common denominator, this is really the same thing as x squared minus 1 over x. If I multiply through by y, I get dy dx.
equals y times x squared minus one. All of it next down. So the same thing, right? What the third one? Oops, I messed up here. This one, the derivative should be one, not x.
Yeah.
So one minus one over x, which becomes just x minus one over x.
Yeah.
There we go. Yeah, we get the same thing. It's slightly cleaner, not having to go through product rule, but yeah, I didn't catch it while I was working this problem. I should have expanded it out first.
What about, that have like acceleration and velocity?
I
So,
think we covered that today, but that's not on the test. So we covered today because we're starting a new unit. Yeah. Oh, double prime is second derivative. That we need to be able to know how to do.
yeah, but is that like considered acceleration?
It could be considered acceleration if you're starting with position and moving to velocity. But for on the quiz, we're not going to use those.
So it's not to say like what is the acceleration?
No.
that's Talking about, like,
I'm going to say find d2y over dx2. So I'm going to say stuff like first notation. Yeah, like this here. Find d2y over dx2. Like find the second derivative. You may have to find second derivative implicitly. So
because whenever it like brought up acceleration, I'll just.
yeah. Well, so yeah, we haven't gotten to particle motion too far. We're going to start getting to that by there.
So page 43. Safety practice problems, I think it's number 2.
Which section?
Chapter 3, page 264, but it's page 43 on the big.
Okay. Which number?
2.
Yeah. So from number 2, I just built the function with everything placed into one thing. So they tell me that v is natural log of x, so I replaced every v with natural log. And I replaced all that into the u. So sine of natural log of x minus natural log of x to -2. And I brought that up to the top just so I can get it ready for what I want to do with chain rule here. Good. So the big chain rule here is sine of u becomes cosine of u times u prime. And u prime is where I have to dig into each of these terms and figure out what is the appropriate derivative. This is 1 over x, but this is chain rule here. I can't bring the -2 down. This is chain rule here. So the -2 could see some -3 minus 1 over x. The reason why is because this is not the same as this. This I can bring down. This, if I bring this down, that's a completely different expression. So this, I got to go through chain rule. I got to think about, okay, there's an outside portion, there's an inside portion, and I got to take terms from each derivative if I want to produce that fully.
So it was like chain rule with like natural log inside.
Yeah,
So you had to like multiply.
yeah. That's a tough one. You're not going to see what that's complicated as that, but it's good to know, follow that path. I think what's good to know is something like number 4 here. You see how this sine to the 4/3 4x minus. This is probably not, it's more complicated than what you're going to see, but you see how there's that embedded chain rule there. There's that outside portion. There's the sine of u, and then there's that u prime. We have to kind of put all that together.
Yeah, it's like double chain rule.
Yeah, it's like double chain rule. But usually that's just like a sine square, right? But either way, I said that, hey, if you see any
Exponent within that notation, put it outside a set of brackets so you can clearly see the outside side portion to build out your chain rule.
So like. How do you build out the chain rule? It's like getting confused.
Yeah, so we identify what is the outside portion, we identify the inside portion, and then we take turns with each derivative. Here's the easier version here. Let's say I assign square root of 3x minus 4. 4x squared. Right. So we don't want to leave that 2 there. That kind of doesn't really help us see the full impact. So I like to have us write it this way. Okay. So what's the outside? There's definitely an inside outside portion, right? What's the, we definitely have to do chain rule here. What's the outside portion?
Parentheses 2.
What's the inside portion?
Sine 3x minus 4.
Okay, so the outside portion, we go to derivative 2 bracket to the first power, that's power rule, would be the inside alone. Now we're ready for the inside. So sine of u becomes cosine of u times u prime.
Trying to like compute it. So it's like. The
Just-
derivative of the outside times the derivative of the inside. Okay.
Remember, the derivative for sine of u is cosine of u times u prime. So that takes effect here. That's my inner portion.
Yeah.
That's my inside derivative. And then here's my outside derivative.
Makes sense. Good question.
I did, but I think you just solved it. Okay, I'm gonna ask you to explain it just to make sure I didn't just imagine that. Can you do number 8 on the test written? On the last page. You didn't know that was.
Okay, this one here?
No, the
Oh,
that back sheet. Yeah. Yeah, that one.
so first we recognize the need for the derivative of arc cosine, which is very similar to arc sine, but it's a negative in front. So negative u prime over square root of 1 minus u squared. And you're good with that. We want to find the slope, so we insert negative root 3 over 10 into the derivative. And it's just a matter of trying to clean all that mess up, but it does come out not too bad. The 1 minus 3/4, same thing as 1/4. The square root of 1/4 is 1/2. You flip that 1/2, it becomes negative 2 times negative 5, which is negative 10.
That's where I got lost. It's not the derivative part, it's
This part here,
yeah,
okay,
that one and the stuff underneath. Those are
Right.
really like.
right. So let's just focus on that portion there. Now, root 3 over 10 is same thing as 3 over 100. Right, now 25 and 100 can reduce, can make that a 4. So square root of 1 minus 3/4. So 1 minus 0.75 is just 0.25, which is square root of 1/4 is simply 1/2. Right, or how about this, square root of 1 over square root of 4?
Oh, because it's 4, yeah, screw, okay, that's the.
So now there's a 1/2 left in the denominator. So negative 5 divided by 1/2, so that doesn't bring it. Okay, so you're good with the order pair.
Yeah.
Now sorry, you go with the slope. So now the order pair here. Okay, so y is equal to arc cosine of 5x. Okay, I know what my x value is. My x is going to be negative root 3 over 10. Okay, so let's figure out what the y value is. Okay, so I'll insert that in for here. Five and 10 reduce, there's a 2 in the denominator, negative root 3 over 2. Okay, so now this goes back to unit circle value. To maybe make things a little bit easier to visualize this, we can maybe think in terms of cosine instead of our cosine. We'll just draw that our cosine to the left side and make it cosine of y is equal to negative root 3 over 2. So we can ask ourselves, cosine of what radian measure will give us negative root 3 over 2? Now, we know cosine is going to be negative in the second quadrant. Okay. And the negative root 3 over 2 relates to 5 pi over 6, because you know the order pair there is negative root 3 over 2, comma 1/2. So cosine of 5 pi over 6 gives us negative root 3 over 2. So we're trying to solve for y, so y must be 5 pi over 6. So that is my y.
How did you like get rid of the part, like you just divided cosines?
So if I have cosine of pi over 4 is equal to root 2 over 2. If I want to isolate that pi over 4, I gotta move that cosine over. So the way I can move that cosine over is I can take the arc cosine of both sides.
Because
That allows me to, because it's inverse, right? So that goes away. So that means pi over 4 is the arc cosine of root 2 over 2.
and our cosine is the same thing as writing
Inverse
a
cosine.
negative.
That's
one,
right. That's right. And if I want to convert this back to cosine, I can take the cosine of both sides. That'll take me back to this cosine of pi over 4. 2. So basically it allows me to move that trig from one side to the other involving.
And you probably said this, but I just didn't catch it, but how could it not be 7, 5, or 6?
So that goes back to restricted values. So for cosine,
Oh, it's in the top two, yeah.
yeah, it's just gonna be the first, and second quadrant. So, yeah.
I forgot.
It isn't
The cosine can only be on the top 2 quarters.
Yeah, because the way that arc cosine is drawn, I think something like this. We don't go past this point, because once we go past that point, then it doesn't turn into a function anymore. So the only way we can keep it a function is we can restrict it between two x values. Because otherwise, your arc trig functions are never functions because they're never functions because they're always going to end up kind of overlapping each other. So we have to cut it off before. Oh, I think something like this, maybe something like this, or otherwise it's gonna keep oscillating like this. So basically, in order for us to make sure that it remains a function, we have to cut it off before it's like this. You gotta cut it off before it overlaps itself.
So if it's cosine, you only look in the first.
First and second quadrant.
And if it's sine,
It's
what's?
that's the first and fourth, because there's positive and negative, and then tangent is first and second.
I'm just wrong.
But yeah, I wouldn't say that's too much of a focus there. It's not
Yeah.
the biggest deal there, but.
And it's tangent one. I know it's not like a big thing.
Yeah, so tangent is going to be
First and second.
And are there gonna be like, those like context questions? Like the, like, interpret this,
No.
no interpret.
Yeah.
Okay, because we had the little quiz, that was one.
Right, we had that for Chris. Yeah, make sure you know, you can make sure you know your derivative rules, right? Go through and memorize them. You're good with the inverse at a point, know how to fill out those tables. Okay.
Maybe not the whole test, what if we forget how to do it, and then we just fill every question?
I mean, that's the easiest one. Do those all day and I'll get a fucking. I'm gonna get this.
Okay. I mean, if you get a chance, I think, I mean, it's a lot, but if you want to work through the entire test review from scratch and just convince yourself, I can do every one of these problems, it should be good for tomorrow. The only thing that I left off the quiz, off the review is the lead. That's right, yeah, like that, right? You gotta take this. Match on both sides, bring that down, product rule, implicit on the left, yeah, okay.
Wait, prodigal?
A product rule, we gotta do a product rule. So let's say I had x to the x squared, or let me show the problem that I did.
Why equal those things? Because. Bring it from.
So bring, take the math log of both sides, bring the x down. And then I do implicit here, but this, I gotta go through product rule. Now that the x is down in front, we have two separate expressions multiplied, so got the product rule.
We'll do every single homework.
Every single one.
Every single homework.
Jeez, like.
Okay, we'll start all of them except the first half of the first day.
Yeah.
And then.
Everything, every one of them except
Yeah,
Like
but for tomorrow,
5%.
if you can just get through that test review again, let that be your focus. If you have additional time, yeah, do the other stuff, but
Yeah, I need it. What guys get on those? What can I get on those? That's a good grade. Since they're all.
they're all late, but I'll still give you an 85 for all of them.
And you said I'll just tomorrow, so.
Yeah, tomorrow morning at 7. Realize that Remind, they're cutting, Fulton County doesn't have like a full agreement with them, so they're cutting mass messages after like Fulton County reaches a maximum, so it's already reached the maximum, so I can't send out a remind message. So I'm trying to figure out how I'm gonna let students know, but
Crazy.
oh well, but maybe I can just start putting messages on my website. I got to do Canvas.
Banned from Remind now?
I can do remind to individual students, but if I want to send to a group, there is a limit for the county, so,
A free trial on that.
yes.
That's, it's like one of those meme like programs you guys.
Yeah, so, I don't know, do you guys get messages through Canvas? You guys-
Canvas.
you don't
but
I
don't
have
even have
my
it.
own teacher that uses Canvas, it's so good.
I
You use that.
I only use it for my GABS class.
Really?
I've heard people using it, but I've never.
I'm trying to figure out how I
Can you group
can
me?
use, because I feel like, okay, if I can't use this anymore, maybe the way for me to get, I can just put,
I could just have an announcements page on my BC calculus page, and just go there and just see what the newest announcement is. And then there's a link to a Teams, also put a link there. I don't know, that's,
See, the only problem is that you can't like notify them.
they can't notify them, right? You kind of have to just know to look.
That's crazy.
Or I can say every day, say, hey, check my homepage. I'm gonna, if there's a new message, then I don't know.
That's so
I know that's still.
So like pretty much everything on Teams uses Remind, so that's really. convenient for the
Yeah.
whole program.
Inconvenient, so I don't know if that's going to make Fulton County say, okay, fine, we'll,
They should pay.
they should pay.
Give us a reminder.
But do you guys get notifications for Teams? Do teachers still use Teams?
My teachers used it a lot last year,
Yeah.
but this year they haven't, but it's only for like files.
I sometimes when they like post an assignment, I get a notification, but only sometimes.
They do
So
post like.
most of your
assignments.
teachers are using Remind, or no? Okay.
Yeah, a lot of my teachers use Remind.
Yeah.
Some
easy.
groups use GroupMe, but most use Remind.
Oh, really?
GroupMe's more for like respond, like having group conversation. It
GroupMe,
still works.
GroupMe, I have GroupMe's for like band and like choir.
Oh, okay.
And a lot of other teachers. do
You could do like a GroupMe for all of the BC students. not
Yeah.
Only 2 classes, and
Oh,
then
okay.
they all get it. If any of them has a question, then it goes to the whole group so everyone can see it.
That's.
And it's free?
Yeah,
Group.
it gets free.
Actually,
I mean, it's free, yeah. You can make your own groups if you want. It's not.
Is that through an organization, or is that the name of it, just called Group?
Yeah, just over-
Yeah,
Is it app?
yeah.
Can I do it on my device? It's a.
I don't know, I only ever use it on my phone,
Oh,
but
so-
it might be on computer too.
That use it.
It probably is on computer, it's probably a website.
I'll look it up.
Yeah.
So that one is like a conversation, it's not a one-way, it's not a
Now-
one-way.
Oh,
announcement page.
But a lot of-
okay,
but
okay,
if-
something like that.
Yeah, and I mean, I don't know what,
So students get chatty, everyone knows.
or someone could say like, oh, when's the test? And then you'll see it and we'll all see it, and then you respond, we can all see it, and it kind of
Oh, okay. But
could be good.
typically, yeah, but I just want to have an avenue for me to just push out information where students can be like, oh, okay, good, I've got to say something. I can just say it in that, before it was Remind, but maybe I can do it through GroupMe.
Yeah, I feel like GroupMe would be probably easier than the announcements page because they'll get it as notification.
Right. And then also, what was I say? If I have. Oh, because when I do reminds, I do schedule, because I don't send out the message at that moment in time. Like when I'm like, okay, I'm gonna send this out 5:30, so I tell Remind, hey, don't send this out until 5:30 in the afternoon.
I don't think GroupMe does that.
Oh, really? So I kind of just
Yeah.
do
That's
it
like,
at that
do it.
moment.
It's more like a texting thing
Right.
rather than like an announcement.
Like an announcement thing.
They need to
Okay.
bring Remind back.
I know. Okay, we'll see. All right, thanks, guys. See you tomorrow. You too.